just resume recording here. And if there's the notes as well in PDF form, okay? So you'll be able to complete those questions there as well. We did plan just to do 7D, but we went through 7D and 7E as well. It was just that 7E allowed us to apply our knowledge a bit more, okay? So today we'll spend a bit of time revising on, I'll do an example or two for from 7E. And then we will go on to 7F, okay? All right, but just before we get that started, I'm just gonna, thank you. All right, so we've got a bunch of data here and it says, the following data was recorded through the National Health Survey. We've got a couple of countries or continents here, or areas around the world. They've been grouped up. And the percentage with eye disease is registered, okay? So 40%, 40.7% are male, and they are from Australia, okay? How do I undo here? Awesome. And 49% are female in Australia or from Australia. Now, with all these values here, we can start plotting them out, okay? You notice here, wait, are you able to see my screen at the moment?
Yeah.
Okay, awesome. Thank you. So based on this, we can start putting in our data. We can see there's one column for males and one column for females. It says which is the explanatory variable and which is the response variable here. So we have to decide or make a decision on which one we're going to take. Anyone have any suggestions?
Country is explanatory.
So you're suggesting that the countries here are explanatory variables?
Yeah.
All right. And what would your
Response would be the percentage.
This one seems a bit strange though, because one doesn't cause the other, right?
But it's indirect correlation.
Yeah, but are the countries considered to be numerical data or is it categorical data? It's just a thought.
Country is categorical.
Yeah, it seems to be categorical, yeah. So there's a bit of an issue here. We can't group these two, like we can't use this data here to put into our scatter plot. We have to focus on the numerical variables. Let's go ahead and read, and if we read ahead, then we can kind of get an idea. The second question here says, construct a scatter plot of these data. Percentage of males on the horizontal axis. So horizontal, if we annotate this, it's glitchy. Whoops. On the horizontal axis, it are the males. And remember how we said that on the horizontal, that's the horizontal part for the E. I'll just write that again. So this means that males will be the explanatory variable and the percentage for females will be on the vertical axis. So vertical is up and down, and that's our response variables. So we're going to be looking at the females for the response variables. All right, so we're going to go over to the CAS here. We don't want to use a calculator in this particular case because we're punching in data. We're going to open up a document. We're going to add a document, list and spreadsheets, first thing you fill out is your titles, okay? What's the title? We would like to usually do explanatory variables first, just because it's in alphabetical order. Explanatory variables, then your response variable. So we're going to focus on males here for the first column. And to get to the second, to get to part B, you just use the arrow and you can type in females and press enter. We start punching our data here at number 1. So don't put it where the equal sign is. I'm going to let in a student. Update the role. All right. So
Good
make sure you
afternoon,
have
sir.
Hey Coda, how you doing?
I'm good.
That's good. That's good. Welcome back. All right. So if you can grab your Kaz and follow along, that'd be fantastic. Thank you. What I'm going to do now is I'm going to start punching in the data. Okay. So 40.7, just making sure you look at the top here in these areas. I'm going to look at this first column here. If you punch in your numbers and it comes up as a fraction, that's okay. We can fix that. So say we've got all our numbers as fractions at the moment. We don't like that. We can go to menu. Let's see here. Or we can go control menu. Let's see. Any way to doc. There we go. So does anyone's calculator turn up as a fraction when you press enter and you type it in? If you do, can you let me know? So I can show you how to change the settings for it to give you decimal points. Anyone? If not, then I'll continue. Maybe it was just my calculator. 71.6, 2.2. 47.7 and 6.0. We need to go to the very top now. So press Control 7. That brings us to the top. 49.1, 66.2. And if you have any issues, please type to me in the chat or you can unmute yourself. No dramas. All right, once you've got all your data punched in, we want to do an analysis on this, okay? We want to find out what the R value is. But first of all, we're just going to construct a scatter plot. We can do that on the CAS as well. In order to construct a scatter plot, we need to add another document. So create page, add data and statistics. That's the one that we want. At the bottom, the horizontal axis, it mentioned that we wanted males there on the horizontal axis and percentage of females on the vertical axis. So bring your cursor, click on that, press females. There we go. We've got all of our data there. So when it comes to the test, or if you're doing this in your exercise books, it's probably a good idea if you try to draw it up accurately as well. So at the bottom here, we've got percentage males. On the side, we've got percentage females. And you need to look at the points, yeah? So it seems here they've already created the scale for us. This value here in the bottom corner is 0, okay? However, what they've done is they've created a break. So in order to create a break, what you can do is kind of do a zigzag line. That shows a break in the data. And that allows you to jump straight to 40 as well, okay? So yes, that is the origin. There's another name for that place there. And thank you, Matt. It is called the origin. We can jump straight to 40 here and go up from there. So 45, 50, 55, 60, oops, 65. They seem to go to 75. So I could just easily say, all right, I just want you to copy this down into your books. But the reason why I'm doing it live as well is so that I can show you the process that I go through. So we have to create these axes first before you can plot out the data, okay? You can see here on the vertical axis as well, it doesn't start, it jumps straight to 50. So on our vertical axis, there is also a break and you go up to 50. Just gonna grab this here, move it over a bit. So we got 50, 56. The increments here are a bit different, okay? 68, 74, and another one up there. So I'm just going to shorten this a bit. Okay, now we can plot out the points. So having a look here, we've got one at close to 40 and 50. We've got one close to 50 and 56. So 50, 56, but it's around here. So just showing you that point there is similar to that point there. Okay, so what I like to do is I like to find the closest corner between two values. So 45 and 68. Then I know it's going to be right there. Sorry, I'm just gonna. There we go. Sorry, I'm so used to this. Okay. All right. So the next point we're going to focus on looking at is the one at 45 and 68. Relative to that corner there, that's this corner at the top here, it's just a one down underneath a little bit. So here it is. Okay. And you keep going. So with your pencil, you'd go and do 56, 50, a bit above that. So I'll pop it right there. All right, and this is how you copy it between your CAS and your book. What else do we have? Got a couple of points up here, 70 and 74. So here's 74, here's 70 coming up. We can base it on these grid lines here. We've got a couple of points here. So one right here, one a bit further along and a bit further up, like a tiny bit. and another one a bit less, but still higher. So here you go. Good enough? Close enough. Okay. So that's the process there of how to translate or get the information from your CAS and bring it across to your book. Okay. So that there answered part B. So that was question B there. So what question was that? Question 5B. I'm just going to write the 5B. Exercise 7E. There it is. All right. The next question they ask us to do is to determine the value of the R value. So the correlation coefficient R, but we want it correct to 3 decimal places. Okay, so there's a bit of a circumstance there for us to consider. 3 decimal places. The value we want to find is R. We can do this on the CAS. We don't want to use this scatter plot anymore. So what we're going to do is we're going to go back to 1.2. You can either use your cursor and go to 1.2 and click on it, or you can go page to the left. So control left. That brings you over to this page again. Now, does anyone remember, or can someone give me the instructions of how to get our R value out? We did this analysis in our last lesson. Just someone walk me through it.
Isn't it menu for 1 and then 4?
On MX plus B or A plus BX?
A plus BX, since we're going to do that in year 12.
Yes. Okay. So what's your X list?
Male.
Yep. We press to the right.
Yeah.
Go down to males. Press the middle button. How do you get to the next line?
Click down. Like,
You click
well, you
down.
can do that too, but yeah.
Yeah. You can either click down or you can press tab. Okay. What about for the Y list?
That's female.
Yep, which is our vertical axis, females.
Yeah.
All right, press tab all the way down to the bottom. Where do we want to put our results?
In
It
the
automatically, yeah, well, it automatically puts it in the next column for us, okay? So if you're happy with that, just press OK. Once you've pressed OK,
control 7.
yeah, nice. Control 7, we go back up to the top. We can't see our R value just yet, so we can scroll down. Bam. There it is. So I'm going to screen capture that. So this was question 5C. We wanted to find out R value. Was that it? Any other conditions?
To 3 decimal points.
All right, excellent. So that's what we're going to do. So I've got our R value, and I'm just going to write the instructions here once again. Menu 4, which was statistics. It's good to write not just the number, because my question is, or what I'm worried about is, what if one day they update it and then it's no longer 414?
And in some calculators, ours are Texas, you could be using a Casio, which may
That's
be laid out totally different. It
Hmm,
actually is.
that's true. 414. So what was it? Linear regression. Now this here is actually really important for us to understand or know how to do, because it's going to lead us into exercise 7F. Okay. So there's the steps there. Our solution was R equals to 0.893.
4.
894. Good. 894. All right. So there it is. We found our R value. Now it says describe the association between the two variables. That's part D. How do we describe it based off the R value?
So from memory, if it's between a certain range, that will determine how strong, weak, or moderate it is.
Right. Okay. So
Look
I
at the
want
graph from
everyone
before.
to. Sweet. So you're on the right track. Now, instead of just going from memory, I want you to open up your notes and find the page or find the table. Once you find the table, can you please type in the chat and let me know what the association is? So we go in the order of strength, direction, and form. Yep. And was there anything else that we had to do here?
State that aloud.
Right. Are there any outliers? Yeah, I'm just going to give some feedback here in the chat. Yep. Correct. Sweet. Thank you. I'm going to wait until there's at least 7 responses. I'm going to start cold calling people. Yusuf, Huda, Haley, Gordon. Can you please type in the chat, please? Make sure you look up your notes as well. And for those who've already typed it out, can you please find the outlier? So finding the outlier.
Can you explain the question again?
Yep. So we're just looking for the phrase. Remember how he said, like, if it's weak, if it's positive, if it's linear association?
So right now I'm just trying to find those notes.
Right. Okay. So find those notes. It's within the document that I sent you. You'd have to scroll up. There's a highlighted section in yellow. See if you can find this. Okay. Once you find this, find out where the R value is along the continuum. on the left-hand side here. And then tell me which one you'd categorize it as. Thank you, Yusuf. Can you please comment if there's any outliers? How can we find out if there's any outliers? Which one looks like it doesn't belong? Can you annotate the screen on Zoom and just draw on my graph there? Or you can draw on the CAS here as well, either one. Which one might be the outlier? Thanks, Zach. Awesome. Yeah, it's the odd one out. Cool, cool. Excellent. So once we've got that, we want to, thanks, Yusuf. We want to be able to figure out which point that is. So what value is that closest to on our X, on our horizontal line? It's closest to 45, yeah? Or you can hover your mouse over the top and you'll be able to see the values. So that there is our outlier. Now remember, it's not just a number, it has an idea. So which country is the outlier? Can you please draw it on the screen or circle it? My question is, which country is the outlier? Right, great, Zach. Oceania. Thank you, Huda. There it is. Other Oceania countries are the outliers of this data set. So there's a couple of things we need to mention. And I'll show you how I'd like to write this out as well for the description. We know that our R value is 0.894. I'll go grab it. If you could clear your drawings now, that'd be great. Thank you. So here's our diagram. R equals 0.894 sits around here within that category. So we can say that there is a strong positive linear association. And the outlier, you need to mention the outlier as well. Other oceanic countries. And just to give a bit more information, males, 46.1%, and females, 66.2%. Okay, there it is. In this here, the way that we recognize outliers is through just observation. Yeah. Some of you may have calculated the upper fence and the lower fence. However, if you try to create, the idea for upper fence and lower fences is mainly for univariate data. So stuff like box plots. Okay, whereas this is a scatter plot, it's a bit different. So we won't be able to use that there. Yar. So that's why, like, if you notice the values could have been a bit different, or you feel like it might not be going anywhere. Okay, bear with me for a second. Bring up the textbook. So we're going to go on to exercise 7F now. And exercise 7F was getting that linear equation out. Okay, we wanted to put out the linear equation. And we wanted to write the equation for it. Now, there's a couple of ways to do it. And sometimes this is actually delving into ideas about from year 12 now. I'll share. I'm going to go ahead and I'm going to share this now. So here's the textbook. You can see here that when we look at the equation of the least squares regression line, there's a slope, there's your A, and here's your A, which is the intercept, and your slope is B. So this is following the line of y equals A plus BX. So going over here, exercise 7F. Title is least squares regression. So having a look, the idea of a least squares regression line, I'll just add in that the fact that it's a line as well, means that we have to look at the data that's been given. And I'll just use the example that we have from here. And what we want to do is we want to actually draw a line that goes through the data. Okay. However, yep, that's right. Is year 11 general similar to further maths in year 12? Absolutely. So what this is going to do is this is going to lead you into next year. So when you cover these ideas again next year, it'll just give you more time to consolidate and understand what's going on. Okay. All right. So the line on top, so this regression line here. So what I've done is I've just estimated and I've kind of drawn it in. Okay. And you can see that for some of the points, it does go through it. But for some other points, it might be on above or below. Matt mentioned a really good word, which was the average. So it somewhat creates the average, right? Between all of these ups and downs. So say when I draw a line in, you can see this line here, it's kind of like on it. This point here is a bit above. This point here is a bit below. You can see the vertical points from it.
Isn't it called the line of best fit?
Yes. So the least squares regression line is also known as the line of best fit as well. However, you can see that this line here is very, very positive. It goes up by a lot to get to that point. So what your calculator is going to do is it's actually going to calculate that in as well. And it's going to kind of figure out, well, since that line is very far away, what we're going to do is this means that in order for us to balance it out, we have to move the line a bit up like that in order to balance out the vertical lines so the vertical lines that go above and the vertical lines that go below the line. Okay, so you can see now that there's more points that are below the line so that it can balance out this line at the top here. Okay, so that's the theory behind it. However, I don't want you to dwell on too much about that. what you need to do, and this is what they're assessing you for, they're assessing you, well, who are they? They is in VCAR. VCAR will be assessing you on how to extract out the formula using your CAS and how you will be able to, so you can see here, right? There's what I just illustrated. So you can see the vertical lines above and below. There's a proper name for that. It's called the residual. Okay. The residual here can also be found on your calculator. You can see there. Those are all the residuals, all the values above or below the actual line. So let's go and create the line because that's what VCAR wants to assess you for. Okay. I'm going to go to that example soon. But let's do it on the example that we already have. So if we want our line, you can see here, regression equation is in the form of a plus bx. So from this here, we can actually just write our formula out. I'm going to go up here and we're just going to write it over here. So our regression equation, or we can call it the regression line, it's in the form of a plus bx, but we know that there is a y equals at the front. Now we know that our a value is 0. Let's just do it to 2 decimal places. So 26.32, there's our a value, plus our b value is 0.65 times x. Okay, so we just got that from the CAS right here. I'm going to screen capture that and pop it on. Maybe I'll just take this section here.
You can also get the regression line by doing it straight on the scatter plot.
Yeah, absolutely. That's correct. So that's one way there. Another way is you can go over to the scatter plot. And Matt, what buttons would you press? Can you lead us through it?
Yeah, so you press menu for analyze.
Good. I like
then
how
you
you say.
6 regression.
Okay.
Oh wait, no, sorry, escape. My bad. Wait. Oh, I already did it. That's why. Okay, anyway, so 6 regression. Sorry.
Yep.
And then number 1. Oh, number
Number
2. Sorry,
one.
number 2.
Number 2. Why number 2?
Because we are focusing on a plus bx.
Yeah, focus on a plus bx. So did you notice that these instructions were different to the ones over in the Excel document or the spreadsheet? So it's important for us to focus on recognizing that as well. What's the, oh, whoops, it just disappeared. Let me get that up again. 4.
No, I only got confused because it said hide because I forgot I already had it up. So
Right. Where did mine go? There it is. So there it is. Is this nice to look at?
no.
Arafat. I'm going to address this question to Arafat. Let me see where he is. Arafat, you here?
Yes.
All right, awesome. What's the problem here for our formula?
The problem.
Yeah. How can you see it going across the screen?
Lines and dots.
Yep. What about the numbers here?
Yeah, the numbers.
Are you happy with the numbers there?
No.
Well, why not? What's the problem?
Mm,
Have a look at
Um,
our answer over here compared to the answer over there on the calculator. What's the difference?
the answer on the calculator is different from the answer. Is a decimal. Is a decimal.
Nice. Yeah. Okay. Decimals. So you're the expert on this. How do we change the decimals?
Or you round them up.
Yep. Well, we can round it off, but how can we do it on the calculator? Do you remember how?
You go on menu
All right.
and you go on fix.
6 settings. Nice.
Fix, yeah, and then after you go display digits,
Okay.
and then you fix it to 2 or 1 if you want to change.
If I want 2 decimal places, which one should I change it to?
Fix 2.
Fix 2. Nice. Legend. All right. I'm just going to use the down arrow here. Fix 2. Press. Oh, damn it. Press enter.
Yes.
Just press. Okay.
Yeah.
There we go. You can drag this equation around as well. Okay. Can I just get a thumbs up from everyone if this process here is clear? I'm recording this as well, so if it's unclear, you can go back and watch it. Anyone else? 5? Okay. All right. Awesome.
I think Gordon's asking a question. I'm not sure.
Oh no, I'm just saying it's like I understand a bit, but I need to rewatch the video.
Okay.
Ah.
No worries. Yep. So you can always just skip to this point here in the video or just scan across until you see the screen jumping around this regression line here. So you notice here, what do you notice about the dots above and below? You see how this line is very far up? Notice that these points here are also negative as well. So the vertical lines and the vertical lines that go up and the vertical lines that go down, they kind of balance out. I'll just show you what I mean here. So if I was to draw on this here, notice that from the line to get to this point here, I have to go down. To get to this point, I have to go up from the line. So there's these up and downs, right? I think that's kind of up. Notice how this line is going very high up. All these points down here that go down is designed to balance that out. But we did mention that this was an outlier, wasn't it? So do you reckon this is a very good line? If we have that point in there? Or do you reckon it's messing up with the actual line? Because remember, this is just one piece of data, yeah? Is it interrupting anything?
Yeah.
Okay. So do you reckon it would be more accurate if we leave it in? Or do you reckon our line will be more accurate if we take it out?
If we take it out.
Okay, so let's try to take this point out here. It was 46, 1 and 66, 2. So I'm going to find that point here. Now, the interesting thing about this is if I remove this, I press delete. And I press delete here. Notice what happens to our regression values. So I'll do that again. Control Z, Control Z. As I delete these values here, I want you to keep an eye on the A and the B value. And I'll just go down a bit. I want you to keep an eye on the R value as well. So I've got to delete these ones, yeah? What do you notice happened to the R value first and foremost?
The value increased.
Right, so it's close to being perfect, yeah? So this is almost, it's a very strong positive linear relationship. Okay. And what did you notice happened to the A and the B? There it is again. If I remove it,
B increases, but A decreases.
correct. Well, let's actually have a look at the line now. Compare the two lines. Which one looks better?
The one on the left.
So this one here, the outlier is removed. So this is important to consider. One day, if you ever come across data, which in your lifetime you probably will, you got to consider if all your data is useful, if all your points are useful, because sometimes some points are useful, some points are not useful. So here you can see the outlier has been removed. And I'll just write here, this graph is more accurate. Or the data. Can I just get a thumbs up if this makes sense? Good. Awesome. Good portion of the class. All right, so the skill that I want you to learn is how to find the equation of the line using the analysis here. So menu 414, and you can get your equation out.
So you're lagging.
Am I? Am
No,
I
you're
lagging?
not.
Your internet might be lagging, Coda. There might be a lot of people online. That's okay. Now, once you got your linear regression line, what do you notice about the variables? Think for a second. What do you notice about the variables? Oops. What kind of variables do we have?
What do you mean?
What are the letters?
It's still A plus BX.
Well, those were actual numbers, yeah? They're not varying anymore.
Yeah.
What do I mean? Okay, I think you're more used to the term pronumerals. What are your pronumerals?
Like, what are they equal to?
Change them to E and R. Ooh, okay. Yes. Yeah, like what are they equal to? You can see here in our formula, in our regression line. It's still X and Y, yeah? Do we want to
Yeah.
use X and Y though?
Oh, that's what you mean. Okay.
Yes, that's what I mean.
So why would be females and then
And X would be
The
males,
males.
right? All right. So make sure we don't just leave it as X and Y. We have to change it. And in year 12, if you leave your answer like this, you won't get the 1 mark. It's tempting to change it to E and R. However, E and R still doesn't explain what the story is about, okay? Or the context of this question. So percentage for males and percentage for females. I'm just going to be more specific here. And I'm going to write with eye disease because that's what it was talking about the whole time. So I'll write that up. Instead of writing Y, I'm going to write percentage of females with eye disease.
Can't you do W/eye disease?
Yeah, you can if you want. No fuss there. Equals to, so that's our Y. Because we're writing the idea now. 26.32 plus 0.65 times the percentage. Oh no, ran out of space. For males, with eye disease. Okay, so notice how we replace the X and the Y with whatever ideas were focused on. Style, fill, these. Okay, so that's how we find our regression line. In the last 15 minutes of our class, I'll give you some time to go through and try 7F. Okay. And in the meantime as well, I will also complete a couple of questions as well. All right, so I'll probably pause this now.
So how many minutes should we take to answer a question like this?
I'll make sure I weigh it. So say for example, a scatter plot there, I reckon I'll give it around 3 marks if I was to get you to draw one up. Okay, just because I want you to include features and it takes time to punch up the data as well, to put in the data into your CAS calculators. So we'll definitely take that into account when writing an assessment. Okay. Does that answer your question?
Yes, thank you.
So, no worries. Scatter plot. We're doing. Ooh. All right. In terms of drawing or constructing a scatter plot, what I might do is when we're back on site, or if we do have to do our hurdle task online, then what I'll do is get you to take a photo of it and email it to me instead. Okay. I might do that when we write up the the graph or the question or the SAC. Find a least squares regression line and determine its equation. Okay. Ping. Why is it glitching? Oops. Okay, there it is.
All right, so have a good day.
All right. Off you go. I'll see you tomorrow, period 2.
Enjoy your day, sir.
I'll see you guys next week.
Yeah.
All right. See you later, sir. Have a great day.
All right. See ya. You too. You too. Take care. Whoops. Stop sharing. Recording there as well.